Greetings from Boston. I'm Kent Larson, Director of the City Science Initiative at the MIT Media Lab. I regret that I cannot be with you today, but at Dean Lowe's suggestion, I'm sending you a quick update on our current work. So we're asking the question, how can we enable more high-performance entrepreneurial communities? And we're engaged in a city science process that has 5 components. The first is data-driven insight. What are the current conditions? Human interaction, mobility patterns, energy consumption, etc. Of course, that alone does not get you anything unless it informs the design of the interventions that can improve on those conditions to transform a society. Urban design, mobility, housing, food, energy, etc. But we need more than that. We need new prediction tools, modeling and simulation to estimate things like the innovation potential, traffic congestion, how the urban experience is improved, the impact on public health, etc. We also need new decision-making tools that can facilitate a consensus. For this, we need to be able to rapidly test scenarios. We need real-time simulation, even AI recommendations. But there is a 5th component that we are excited to explore, which would be new governance systems, how to achieve a kind of civic homeostasis. And I'll talk about each of those, but of course, this process does not happen in a linear way, so we're looking at new tools where we can engage in each of these steps simultaneously. So let's talk about each. Data-driven insight, understanding current conditions. Well, we do this in a number of ways. First of all, we have built in my group tiny little sensors that we can sprinkle around an environment. We call these termites, the 3rd version of MIT environmental sensors. And for example, we deployed hundreds of these sensors in apartments around the world. This is an IKEA Living Lab apartment. The bouncing ball here shows the sequence of sensor activations as an individual went about activities of daily living, in this case preparing a meal. The bigger the sphere around the sensor, shown in yellow dots, shows the number of sensor activations, so we can tell what systems people use, what systems they don't use, etc. We also can engage in a similar process at the scale of the city, in this case using mobile phone CDR data to understand mobility patterns. In this case, this is Andorra. The orange dots are Spanish people, the blue dots are French people, and this shows the activity during Cirque du Soleil. And we can use this kind of data to predict where there might be traffic congestion, as shown here in red, or where people gather in the community. Okay, transformation, the new systems to improve on those conditions. First of all, urban programming. This is a kind of pre-urban design, and just as a case study, we took Barcelona, beautiful square blocks of the 19th century Cerdà plan. Each block has 16 optically tagged building elements, and we can model millennials in blue, mid-career in yellow, senior executives in red. And here you see how the millennials in blue dots are flowing into the center of the city as we bring affordable housing, micro units, into the areas where mid-career and senior executives inhabit. Mobility on demand, alternatives to cars to increase density, efficiency, and vibrancy. These are all the mobility modes that we're looking at. Walking is the most important mode, shared bikes, etc. The vehicles shown with red boxes are the ones that we've prototyped in my group. Just one project that I'll show you. It's our PEV project, Persuasive Electric Vehicle. We position this something between stationless shared bikes like Mobike and Ofo, and new ride-sharing programs like Didi, incorporating the best features of both. So this shows our Persuasive Electric Vehicle project. One would call for it like you would for a Didi ride. You can drive it to your destination. It's fun to drive. It can be used in autonomy mode if you're disabled or elderly. A routing algorithm will pre-position the vehicles. We're using computer vision to recognize bicycle lanes. and LiDAR systems to recognize moving vehicles and people. We're looking at very low-cost infrastructure like spray paint to give precise positioning, optical tags in the environment, doing edge detection. We also have designed this to interact with humans in a very natural way. You can see it doing a little jog around people, or someone stepping in front of it. It stops just inches away. We're building a series of these vehicles in our lab in Taipei, collaboration with Taipei Tech, and here you can see it being tested in the Taiwan Air Force Base. And of course, we designed this to move people, but off-peak, it can also function as a kind of land drone to deliver packages. Places of living and work. These are hyper-efficient environments to increase equity, livability, and affordability. So there's been a lot of hype about micro units. Most of them, I think, are badly designed. So we decided to explore architectural robotics, so a small space functions like a much larger space. So we can have a dining room for 6, a fully functional office, a queen-size bed, a living room for 6 people. We can do this by having a tiny little powder room-like bathroom that opens up to give you access to a washer, dryer, and shower. Now, we've spun this off as a commercial effort. This is Ori, and what we're showing here is an Airbnb apartment we operate in downtown Boston. So this young woman puts her bed away in an automated way, effortless, almost magical way. When she gets up, she collapses her bedroom. So she has a much larger living room during the day. And we're exploring new ways of architectural transformation. In this case, rather than horizontal transformation, it's vertical. The bed comes down over a living space. Predicting impact, number 3, modeling and simulation of urban interventions. So this is the Cityscope platform that consists of a physical table with optically tagged Lego pieces that can be interactively moved to change land use and density, a tangible interface. Then we project onto that different simulations. We have a radar plot of urban performance, key performance indicators, a 3-dimensional model, agent-based simulation. This shows the radar plot of urban performance, where we have the various types of density, residential density, employment density, third places, day and night, restaurants, cafe, cultural venues. And then we can also map those diversity elements to residential employment, etc. And we can look at proximity, access to parks, mass transit. So each community can have its own fingerprint as such. Then we can look at building energy per person, mobility energy per person, social well-being, innovation potential, safety, security, those kinds of things. And just to give you a sense of how this works, this shows the use of the Cityscope model, where the land use elements can be rearranged, the densities can be tuned. In this case, you can see traffic congestion in red as we toggle from private cars to shared use vehicles. The roads go green, we can increase the density. Or in this case, moving residential L, those are luxury apartments, tuning the density C, where then the affluent people are inhabiting the city, or micro units for young people. In this case, 12 micro units per Lego brick. And as we tune the densities, we can update the urban simulations in real time using agent-based modeling. So in this case, you can see the movement of different types of people, the same color codes where millennials are blue, for example. And where are people interacting? Showing the web of social interactions, which is a good indication of the innovation potential of a district. Number 4, decision-making, facilitating a consensus. I'll just show one example of this. In Hamburg, Germany, several years ago, there was a mass influx of refugees from the war in Syria. And of course, it was a huge challenge to find appropriate housing, long-term housing for the refugees. The challenge, though, was not how to build the housing. The challenge was how to identify sites in the community acceptable to build housing. So in this case, with our partner, Hafen City University, there were 44 workshops, roughly 30 people each. They would discuss interactive maps that were presented onto the table. They would place a plastic square that could be recognized by a computer vision system over the area of the city that they thought had potential for refugee housing. This created a zoom window on a second table where they would interactively move the optically tagged Lego pieces representing number of units and immediately get feedback as to proximity to schools and mass transit and shopping and the like. At the end of the workshop, the table would look something like this. They would come back and discuss this. And so this was presented as Germany's radical pro-refugee urban planning experiment in the Atlantic recently. And the fifth step, governance, towards healthy, high-functioning communities and reinforcing prosocial behaviors. So today, we have a centralized economy. Property is owned and controlled by the few. Systems are optimized for financial return. Decision-making is top-down and opaque. But in the future, we will see decentralized token economies enabled by blockchain and public ledger. Residents can be both consumers and investors with equity, and a local economy can have rules and exchange rate to optimize for social performance, cultural performance, environmental benefits to the community, forming a kind of token commons. So I hope to be with you in person at your next event. Best wishes for a successful conference. Thank you.